guided missile has revolutionized the modern battlefield. This video ordnance program examines the impact of missiles on warfare, on land, sea, and in the air. The dominant weapon in land warfare since the Second World War has been the tank. Today, guided anti-tank missiles are the most serious challenge to tanks on the modern battlefield. Their shaped charge warheads can bore through nearly a foot of steel armor. If they hit the tank's vulnerable ammunition, as we see here during a test firing, the results are catastrophic. Most contemporary anti-tank missiles use wire guidance. When the missile is fired, a thin wire, hardly thicker than a human hair, is spooled out behind it. The launch station automatically tracks the missile gunner keeps the launcher pointed at the target, and the guidance system in the launcher sends signals to the missile through the wire, which correct its trajectory. Anti-tank missiles come in different sizes, tailored to different missions. Medium anti-tank missiles are designed for the infantry. They must be easily portable. A good example is the American Dragon anti-tank missile, which can be carried by a single infantryman. In Europe, the Euro missile Milan is the preferred anti-tank weapon for infantry. It uses a two-man crew and has an effective range of 2 kilometers. The Milan can also be fitted with a mirror night sight, which enables it to be used at night as well as in daylight. The success of weapons like these and their Soviet counterparts has led to improvements in tank protection. Tanks now use chobham armor or reactive armor to protect against missiles. This has led to further improvements in the missiles, like tandem warheads, which can defeat reactive armor.
Stop.
The Swedish Bill missile uses another approach. Rather than attack the thick frontal armor of the tank, protected with layers of advanced armor and reactive armor, the Bill instead attacks the thin roof armor. It is programmed to fly over the tank, and when in the right spot, detonates its warhead downward with dramatic effect. Conditions on a possible European battlefield have led to other specialized approaches, such as the new Aerospatiale Erex missile. Because of their speed, medium anti-tank missiles cannot be guided for the first few hundred meters of their flight, so they cannot be used at close ranges, such as in city fighters.
This is an urban combat missile, which can be fired from enclosed spaces. It leaves with a very slow speed, and its guidance system allows it to maneuver at short ranges. The infantryman can launch it while in towns without worrying about the backblast, like the type that would come from a high-speed missile.
Work is now underway in Europe and America on a new generation of medium anti-tank missiles. In the United States, the new program is codenamed Ordnance, and in Europe, the program is called Trigat. The Euromissile Consortium is developing the Trigat, and one of their senior officials describes their objectives.
In our design of a third-generation medium-range missile, we sought a technical and economic balance. A medium-range infantry anti-tank missile must be produced in large numbers and must also be kept at a cost compatible with the tight budgets towards the year 2000. We are leaning towards laser beam guidance, a tandem warhead to defeat the future tank threat, especially reactive armor, a launch mode for engagements at very short ranges, and a low-speed launch to permit firing from bunkers and basements for urban combat.
Besides the portable medium-range missiles used by the infantry, there are also heavy, long-range anti-tank missiles. These missiles can hit with pinpoint accuracy at ranges over 3 miles. The best known of these is the American TOW missile. The TOW is mounted on armored vehicles and on helicopters. The combination of helicopter technology and guided missiles has created one of the tank's most deadly enemies, the attack helicopter. The TOW can also be fired from armored vehicles like the M2 Bradley infantry fighting vehicle. In Europe, the counterpart of the TOW is the Euro missile HOT. As in the case of the TOW, it can be fired from both armored vehicles and helicopters. The laser-guided Hellfire missile supplements wire-guided anti-tank missiles like the TOW. The Hellfire was specifically designed for use from helicopters like the U.S. Army Apache. It is the most powerful anti-tank missile in service today and can hit targets over 6 miles away. The Hellfire is laser-guided. The Apache weapons operator aims a laser designator at the target, and the missile homes in on laser light reflecting off the target. Future generations of heavy anti-tank missiles will not need wire or laser guidance links, but will use advanced seekers which automatically home in on the target. Another unique guidance system being developed for anti-tank missiles is fiber optic guidance. The missile trails an optical fiber which conveys the video image from the camera in the nose of the missile back to the operator. The operator can actually see the same video image of the target seen by the missile. The operator can steer the missile into the target with great precision. This will permit the development of missiles which can strike targets at much greater ranges than now possible, perhaps as far as 30 miles away. These missiles could also be used to attack low-flying helicopters. There are 2 such missiles in development, the FOG-M in the United States and the Polyphem in France and Germany. Another way to attack land targets is with ballistic missile artillery. The United States Army's MLRS artillery rocket system can attack concentrations of tanks and other targets using small, scatterable bomblets. The new Army TACMS has greater range and a greater payload. Future versions of MLRS and TACMS will carry guided submunitions able to hunt out tanks with pinpoint accuracy. For a century, the traditional weapons of naval warfare have been the gun and the torpedo. But with the advent of miniature radar guidance seekers and advanced electronics, anti-ship missiles are joining the naval arsenal. Perhaps the most famous of these is the French Exocet. Weapons like the Exocet can be fired from surface ships, aircraft, or even submarines. Its American counterpart is the Harpoon. This type of anti-ship missile contains a small radar in its nose. After launch, they are programmed to skim over the sea at very low altitude so that enemy ship radars cannot detect them. Their radar seekers identify the target and steer the missile for precise impact. The sophisticated guidance in the harpoon permits a wide range of tactics. The missile can be programmed to fly over or around obstructions, like small islands. They can also be programmed to fly a false heading, luring their intended victim into thinking that they are aimed at a different target. At the last moment, they change their course. Submarines have traditionally relied on torpedoes to attack surface warships, but now they can also fire anti-ship missiles from underwater.
The main weapon to attack a surface ship is a torpedo. Increasingly now you're also seeing submarine-launched missiles, like the French Exocet, the American Harpoon. There are a variety of Russian missiles, SSN-7, SSN-3 to some extent, where the submarine can stand off at a greater distance and fire.
Submarines can also fire specialized anti-submarine missiles like Sea Lance. Sea Lance is a rocket-propelled torpedo. It is launched like a missile and has the speed and range of a missile. But when near the target, it releases a torpedo into the water to seek out a hidden submarine. Anti-ship missiles can also be fired from a variety of launchers. The British Sea Skua, for example, is small enough to be carried by a small naval helicopter. The Franco-Italian Automat missile can be fired from a ship, but also from coastal defense launchers to protect harbors from enemy ships. The Soviet Navy is best known for its very large anti-ship missiles, which are nearly the size of a jet fighter. The massive tubes on the front of this Slava-class cruiser contain 4 SSN-12 Sandbox anti-ship missiles. They are intended to attack large surface warships like aircraft carriers. Future generations of anti-ship missiles are likely to be supersonic, making it far more difficult for a ship to evade them. An aerospatiale official describes such a missile, the new ANS.
Its advantage resides essentially in the missile's capacity to avoid enemy defenses. It benefits from a high degree of stealth features, by an ability to defeat countermeasures, and finally, by supersonic speed. In fact, more than Mach 2.
Naval missiles can also be used to attack land targets. The U.S. Navy's Tomahawk cruise missile uses a special guidance system called TERCOM to seek out land targets. The missile's computer contains a map of the target area, and it compares the radar images of the terrain below it with the computer maps stored in its memory. This allows precise attacks against pinpoint targets miles inland. These targets can also be attacked with special submunition warheads, which scatter a large number of small bomblets over a wide target area. Since the 1950s, the missile has gradually become the primary weapon in air-to-air combat. Undoubtedly, the most successful dogfighting missile in history has been the AIM-9 Sidewinder. The Sidewinder has an infrared seeker that homes in on the hot exhaust gas of an opponent's jet engine. The AIM-9 is tailored for close-range combat.
In the dogfight mode, they designed the AIM-9 missile, which gives it a quicker launch, a faster acceleration. It's a much quicker missile to get to the threat. Therefore, in a shorter range dogfight arena, you want to have that missile which has the capability to get to them as fast as possible and kill the adversary quicker.
The capability of the Sidewinder has improved through time due to its new and more sensitive heat-seeking guidance. With early Sidewinders, the pilot had to maneuver onto the tail of an opponent, where the hot exhaust gas of the engine was most obvious. New versions of the Sidewinder, like the AIM-9M, are so sensitive that they can lock onto the heat generated along the forward edge of a fighter by air friction.
early version of the Sidewinder was basically a stern aspect where you had to shoot from dead six at the target, almost straight and level. We've evolved now into the later types, later generations of missiles, the AIM-9 LM, and so on and so forth, that have a very good maneuvering capability. They have very good infrared discrimination. You can shoot at much different angles, up to sometimes including almost head-on. If I were up against that kind of missile, I would sure handle my tactics a lot different than against an earlier generation AIM-9. Oh yeah, the advances in missiles have made a tremendous difference in air combat, no doubt.
The other major method of missile guidance for dogfighting is radar guidance. The aircraft's radar illuminates the target and the missile homes in on reflections off the enemy aircraft. Radar signals travel much farther than infrared energy, so radar missiles can be used at much greater ranges than heat-seeking missiles like the Sidewinder. Often, fighters will carry heat-seeking missiles like the Sidewinder for close-range engagements, and radar-guided missiles like the AIM-7 Sparrow for long-range engagements.
The F-15 carries three types of weapons. We carry 4 radar missiles, the AIM-7. We also carry 4 heat missiles, the AIM-9, and we carry the gun. The AIM-7 is a radar missile, as I talked about, and that's primarily employed in a beyond visual range environment. We do not see the other airplane. We see them only on the radar normally, although you can shoot it in closer. So that's normally to get that first shot of opportunity. Once you've ID'd the target as hostile, take that first shot.
Dogfighting missiles have been developed in Europe as well. The French Magique is an infrared-guided missile and a direct counterpart of the Sidewinder. The radar-guided Super 530 fulfills the same role as the Sparrow for long-range air-to-air combat. The British Skyflash is an improved version of the Sparrow. The most powerful air-to-air missile now in service is the U.S. Navy's Phoenix missile. The Phoenix has double the range of the Sparrow missile, over 125 miles. The sophisticated interface between the Phoenix and the F-14 Tomcat's powerful radar allows the Tomcat to engage up to 6 targets simultaneously. In the future, these features will be found in smaller missiles, like the new AMRAAM. Missiles also extend the power of aircraft when attacking ground targets. The AGM-65 Maverick is fitted with a special imaging infrared seeker that can lock onto ground targets with pinpoint precision. After the seeker is locked on, there is no need for further guidance corrections from the pilot, as there was in older generations of air-to-surface missiles. Attack aircraft are threatened by new advances in anti-aircraft missiles. To avoid these defenses, new missiles are being developed which can be pre-programmed to avoid enemy missile sites. A good example of this type is the new Matra Apache. The attack aircraft can fire the missile from outside the range of enemy anti-aircraft defenses. The missile flies itself to the target area. The Apache can attack different types of targets depending on its weapon load. Enemy airfields are a particularly important target and can be attacked using runway cratering munitions. Tank formations can be attacked using special submunitions. Missile-armed attack aircraft and combat helicopters pose an especially serious threat to ground forces. Not surprisingly, armies have turned to missiles to defend themselves against the air threat. defense missiles come in many sizes, from short-range systems that can be carried by an infantryman, like the Javelin, through highly complex systems that can hit enemy aircraft 40 miles away, like the Hawk. The first man-portable air defense missile was the U.S. Army's Red Eye, developed in the late 1950s. It has been replaced by the new Stinger missile. The Stinger uses a sensitive infrared seeker that picks up the heat given off by modern attack aircraft. It has a maximum range over 3 kilometers. The effectiveness of the Stinger was clearly demonstrated during the war in Afghanistan. The noted defense analyst David Isby traveled with the Mujahideen resistance during the war and explains the Stinger's importance.
Starting in 1986, these were supplied to the Afghan resistance, and they have been used, it appears, most effectively. According to U.S. government sources, no less than 68% of those fired have resulted in shot down Soviet airplanes or helicopters. In the June 1987 Soviet offensive in Paktia province, which is one of the areas where there's been the most intense fighting in Afghanistan, the Soviets have had to reduce the use of helicopter gunships, which up until now have been their primary offensive weapon in Afghanistan.
The Stinger can also provide fast, mobile air protection night as well as day. The United States Army uses a pedestal-mounted Stinger called the Avenger. The French Army's new Mistral missile is similar and also uses infrared guidance.
The Mistral is a short-range infrared missile, about 7 kilometers in range. In our view, it is the most advanced system in the world today. It has been in service since the end of 1988. It is used by 6 countries, and we estimate 10 uses by 1990.
Another missile used in Afghanistan was the British Army's Javelin. The Javelin uses a different guidance system from the Stinger or the Mistral. The missile crewman places a small cursor over the target using a finger control, and the missile is automatically steered against the target. The British Army is currently developing an even more sophisticated successor to the Javelin called the Star Streak. A third approach in man-portable missile guidance is found in the Swedish RBS-70 missile. The RBS-70 operator directs an invisible laser beam against the enemy aircraft, and the missile rides along the beam into the target. To protect maneuver forces against aircraft, air defense missiles are mounted on tracked vehicles. The Chaparral is a medium-range missile system used by the U.S. Army. The missile itself is derived from the famous Sidewinder dogfighting missile. It uses infrared homing like the smaller Stinger. The U.S. Army is now developing a successor, the ADATS, as part of its Forward Area Air Defense Program. The ADATS uses new laser guidance technology. Modern attack helicopters are now employing infrared flares to confuse heat-seeking missiles. As is apparent here, they do not confuse a laser-guided missile. European armies have favored radar-guided missiles. The Protal is used for air-base protection, and it has been widely exported. German and French armies used the radar-guided Roland missile system. A senior Roland program engineer describes the current effort.
Roland système se trouve actuellement en fabrication de grande série
The Roland is now in service with 10 countries, 3 of them in NATO. There are 540 launch systems and about 25,000 missiles in service today. It is an air defense system to protect against low and very low altitude aircraft. Originally, it was designed to escort mechanized formations, and its use has been extended to defend fixed sites, such as command posts and airfields. It is being modernized both for the French and German armies.
Air defense missiles for high-altitude protection are the most sophisticated variety of anti-aircraft missiles. The most widely used missile of this type is the Hawk, first developed for the United States Army in the 1950s. It has been continually upgraded, and the most advanced version is called the Hawk Phase 3. The Hawk system includes long-range surveillance radars to locate and identify enemy aircraft, and illumination radars, which are used to guide the missile to its target. Although the Hawk is designed primarily to intercept aircraft, as early as 1960 it demonstrated its capacity to engage even tactical ballistic missiles. The Patriot system is the successor to the Hawk. Patriot is the most effective high-altitude tactical air defense missile system in the world today. As missiles become more sophisticated, electronics form a greater and greater portion of the whole system. Patriot is centered around a phased array radar. Unlike conventional radars, which rotate while searching, the phased array radar steers its beams electronically. The Patriot's phased array radar can track up to 100 targets and control up to 5 missiles simultaneously, a considerable improvement over the older radar guidance systems. The radar sends out a special electronic signal that illuminates the targeted aircraft. Then it tells the missile to open up its receiver and pick up the reflected energy. When the missile receives the reflected signals, it reports back to the main radar, telling it what energy it sees. The computer then sends course corrections to the missile via the radar to ensure a very precise interception. Although this track-via-missile guidance method is extremely complex, it makes it nearly impossible for an enemy aircraft to jam the missile guidance system using electronic warfare equipment. Over the past 2 decades, the role of missiles in modern armed forces has continued to grow. Missiles are now an essential ingredient in a whole range of modern weapons, including combat aircraft, warships, and armored vehicles. High-tech missiles give today's soldiers the critical combat edge on the battlefield.